Okay, good afternoon, everyone. Thanks for joining us for this installment of Data Bytes. We're talking about the command line. What is it good for? What's the deal with it? And let's just jump right in. So first of all, what is the command line? And if you take a look at my first slide here, if you're a Windows user, that might look familiar, that bottom line, the C:\\, with the little angle bracket there and the blinking underscore. That is what the command prompt in Windows has looked like going back to the days of MS-DOS, which was the operating system that predated Windows before it was a graphical interface. So this is going back multiple decades at this point. And we'll see, so that's the command line in Windows. And it's a very similar thing if you go to a Mac or a Unix-based operating system. You will see a line of some sort of text, and then you'll see a blinking cursor, and you enter text, and you hit enter, and thus you issue commands on a line. That's why we call it the command line. So that's a pretty basic thing if you just think about it in that sort of holistic sense. Strip away every aspect of modern computing as we know it when it comes to desktops, folders, menus, every bit of clicking you've ever done. The command line more or less operates in a mouse-free, touch-free environment. Everything on the command line you can accomplish using just the keyboard. Now, I will say that in recent years, like the last 10, you can now interact with the command line using your mouse a little bit. So it's not been totally stuck in the past. So why would we want to use it? Let's talk about the good. So using the command line lets us to accomplish what we are looking to do very, very quickly. Particularly if you're doing, and I will repeat this again and again, and that's kind of apropos, the command line allows you to very quickly perform similar tasks over and over. If you've ever done any computer programming, chances are you've used it to, especially if you've used it in a scientific or academic data science related way, you've used coding to, say, loop through and deal with any number of tasks that need to be done. And that's very similar with the command line. It's repeatable. So once you've deciphered the syntax of, well, first you've deciphered what tool you need to use, what command you want to use, and then you've deciphered how to form how to form the command. Once you've done it once, you can just copy that text, paste it into a text document somewhere, and then you'll have it, and you can copy and paste it back onto the command line and reuse it at a later date, which is great. And I'm making a bad joke. It's repeatable. I repeated that. Self-documenting, just like I said, you can take that code or that command and you can copy it. And as long as you understand how to access the help functions or the documentation for a command line tool, you can fairly easily put together what you did with it. So, and then in the case of something like called a batch file, which is what in Windows environments we use to take many commands that you would execute at the command line and stick them into a single file. So you can execute 5 to 10 commands. It's a script is the way to think of it. It's modular. And by modular, I mean you, for the most part, this is true with the command prompt in Windows and MS-DOS, and also with the Unix family of of command line tools, which includes the Mac OS. There are very, very small programs that are written with super specific tasks in mind, micro programs you could call them. And a real common trait of these programs is that they are meant to be linked together. So you can use some of what we'll see this a little bit later on, but you can chain commands together, and you can take the output of one and make that serve as the input to another command, and so on, and then all within one single statement, which is pretty cool. And when you've done it a few times, it's pretty outrageous. And it's frequently free and open source. This is not true of the Windows stuff, but very much so with the Unix world. Okay, the bad. So it's not all daisies. There's definitely an overhead involved when you're getting started. It's not something that just looking like the benefit of working with a graphical interface is that you can look at the menus and you can just kind of browse around and see what's there. You can hover your mouse over, and that's usually a way to get some info. You do not really get that with the command line. At the very least, you need to know how to access, well, you need to know what the commands are. So that's hard enough. And then you need to know how to use the different commands. So that is another layer of overhead, where you need to just be able to read the documentation or see the help for a particular tool. And then you can get to the point of deciphering how the syntax goes together, and what /f means, what -p means, what -uppercase-P means, what is different with certain things. So that there's just it's very memorization reliant. That's something that, in order to really feel that it's worth your time, you're going to need to do it enough, or at least go through the motions enough so that you can come back to it and quickly remember. So you don't have to memorize it exactly. I'm not going to pretend that I recall how to do all this stuff totally off the top of my head. Some of it, sure, but a lot of it, it's sort of like, oh, what is that again? And then you quickly know how to either just use a web search or how to use the help pages to figure out what you need to do. So it's like, as long as you have some kernel of memory for how you did something, you can figure it out. It's difficult to intuitively problem solve. And by this, I mean that it can be difficult to know what is available, like what potential solutions are. So that can be tricky for you to say, I have this problem, I need to accomplish this. How do I go from A to B? And without knowledge of what those commands and tools are, you might not be able to make that leap. But at the same time, I'm hoping with this talk I'm giving today, I'll introduce you to a lot of these different tools, and just making you aware of the existence of this sort of ecosystem, and that you can do a search for command line tool to do blank. Like, that's something you could put into Google, and chances are you'll find something that might fit your needs. And once you see what we can do, you might see why that's worth it. That's my hope, at least. And something that can really bite you, and that's bitten me, is that the fact that there's generally no undo option. So if you're working on a command to rename or to move the contents of one directory, and you end up deleting them all, chances are, I'm pretty sure it doesn't go to the recycling bin. So that's something where you could get yourself into trouble, but that's easily solved. If you beforehand be sure to back up everything, or just have solid backups of all your work. as a general practice, and that will allow you to prevent any heartache when it comes to files you've potentially lost. Or if you're like me, you just have to email your department's IT person begging for help to access their backups because you deleted something on a network drive. Not that I've done that, actually I have. Okay, real quick, I'm going to introduce sort of rapid fire a number of commands on the Windows side, and there's sort of counterpart on the Mac side. And Mac, it covers Unix, but honestly, if someone's using Linux, Unix, whatever, they probably know what command line is, just because that's sort of a leading indicator. So I'm just going to focus on Windows and Mac. So that I'm just going to go top to bottom and quickly describe what they do. CD, change directory. That's how you navigate through the command line. You remember C:\\\. That was meant you were at the root of the C drive. If you wanted to go into the folder called documents on the C drive, from C:\\, you would say CD space documents, and that would be change directory into documents. And that works both for Windows and Mac. Now, if you want to see the contents of a given directory, you in Windows would use the dir command, dir, and on Mac you would use ls. These do the same basic functions. They show you the contents of what you're looking at. And as is the case with every single command that we're going to see, there are tons of options and sort of variations that you can use for each command. So just in general, it's nice to remember that for each command, there's usually a basic usage that will get you through a lot of what you need to get through. But then for those remaining sort of edge cases, there's usually some sort of what's called a flag or an option parameter that you can use to get over that final hump. Copy and CP and robocopy. Windows has a super basic copy command. That's just copy, and that's just like making a copy of a file. That's it. That's all it will do. And robocopy, which is just a hilarious name. I don't know if it's based on RoboCop or what, but I just love it. I like to think it's RoboCop related. Great movie if anyone hasn't seen it. But robocopy is it's a robust copy program for Windows, and it lets you do all sorts of things. It's a way to create a mirror of a directory from one to another. It's a way to copy file metadata. So if you want to move something without changing its date modified, this is kind of library focused. I shouldn't go that far, but that's where robocopy can come in handy. And CP, you see there's a blank next to robocopy, and that's basically because CP can do everything that robocopy can, just all in one. So there's no separate tools to worry about there. Cls and Clear, those just clear the screen. So if you're, and I'll show you an example of that when I do a little hands-on, but it just clears the contents of your terminal or your command line screen. Delete and RM, or del and RM, that's for removing or deleting files or data, files or directories. And I threw SFC on the end for Windows, and I don't know if I should have, it doesn't really fit here, but it's for checking your file system in Windows. It's a useful utility. And yeah, I don't think I should have included it on there, but that's okay. Okay, one thing before we kind of jump in to me demonstrating just actually doing things with these things, with these tools, I'm sorry. If you want to use the tools available to a Unix or a Mac user, and you're using a Windows machine, and you'll see, I'll try and be clear about what is what as we go through some of the different examples. But there's a way, I use a program called CYGWin. I don't even know how to pronounce it. That's the problem with this internet stuff. But it's a way to install any sort of Unix or Mac command line tool onto a Windows machine, which is super handy. It's totally free. And that's what I use on a daily basis because all of my computers here at the library are using Windows. So that's how I put these together. And I'll just throw in extra nerdy stuff if you want to be able to just use all of the tools this program provides within the normal command prompt, like the CMD environment in Windows. You need to add the cygwin path, the bin path to your environment variables. Ugh, don't worry about that. Okay, just firing off. Here we go. This is where it's going to get super exciting, I think. If you say you are creating a website and you want to test, you want to serve your content. If you've ever done any web development, you know that if you have JavaScript, which is sort of the programming language of the web, if you want to work with it on your local computer, so you're not publishing it to a real website, if you're just working on it on your own computer, you need to basically use a web server to mimic how it will look and how it will behave on an actual web server. So we can use Python and Python-m simple HTTP server, hit enter. And if you have Python 2, that will start serving your current directory as though it were a web server. So you'll see here that it says serving 0.00 on port 8000. That's where you would go in your web browser. You could go to 0.0.0.0:8000 or just localhost :8000, and that would it would be as if you were accessing that directory on a website. So very handy. And if you're on Python version 3 or up, very similar syntax, but a little different. And you can see what version of Python you have by Python-V. Okay, now this is on Windows. Let's say you have something downloading, or if you're doing just any sort of task that you have working that's going to take, it's going to take 8 hours, and it's Friday at 5 p.m. and you're ready to go home, but you don't want your computer running all weekend, but you know it will be done in 8 hours. That's where you could go to your command prompt and use the shutdown command. So here you see I have shutdown -s-t and then 3600. And so this is an example showing switches, which I mentioned before, or options. I like switches, it sounds mechanical. So the -s means to turn off, so shut down. You could alternatively use -r, and that would restart your machine. But for the purposes of this example, we're using -s to shut down. And then you can set a timer with -t and then the number of seconds you want the timer to run for. So, and that's in the number of seconds. So if you, it can get a little goofy. So 1 hour is 3600 seconds. If you wanted 8 hours, that would be 3600 times 8, which is what, 24,000 plus 28,800, something like that. But then that would be it, and it would shut itself off. I've used this once in a while. It's pretty handy. It's also useful if you are working remotely on if you have a server that you only have command line access to, but you need to restart it. That's frequently a case if you've ever worked remotely on a command line only server. And if you ever set the shutdown timer and you made a mistake or you want to cancel it, you can just abort using -a. Pretty cool. Okay, now this is really, I think, handy for those of us who have ever done any sort of academic project or research involving code, or not even code, just files in a project directory. you can use the command called tree to output, just by saying tree, it will output the folder structure of starting from wherever you are. So you can see on the example here, I'm in C:\workspace/catcher script, and then I executed tree, and that shows you I have 3 folders within that directory called archive, completed, and WPA MSF. And so that's handy enough, but you can also use the /f, and this is also a switch, and you'll see you can sometimes see tools use the dash for switches or / for switches, and it just kind of varies. The / is more common with the Windows environment, and the dash is more common, I would say, with the Unix environment, but it doesn't really, that doesn't really follow. It's not a hard and fast rule, but you can see it lists the contents of the root directory there at the top, and then it shows each of the component or subdirectories and each of the files inside those subdirectories. You can see I have some obnoxiously long named files in the archive there. So that, I mean, that's okay. And if you've ever tried to copy the content of the terminal to like copy and paste it, it doesn't really work well with your mouse. It works, but it's kind of wonky. So you can actually use the pipe, which is that, see that vertical character. It's usually it's on my keyboard, at least, it's on the same key as \. You just have to hold shift. And so if you take pipe and then clip, which is the clipboard, it will take the results of whatever command you entered and directly put them onto your clipboard so you can paste them. And you can do the same thing on a Mac using pbcopy. So just as an example, I put tree /F pipe clip. It looks like it did nothing, but then I go to Notepad, paste it in there, and there you can see there's my nice little layout. So tree /F pipe clip, enter, and paste. And so you can imagine that this would be an extremely useful thing. If you've ever used GitHub, which is a social coding open source hub for sharing projects, data, things of that sort, using the tree command to get that output, and then using that to structure your documentation, or just as a illustration to include in your documentation, very, very helpful. And it can help, really help make sense of the lay of the land of your project. Now, if you want to, this is an example of just using looping options, the looping commands that are available in, this is also in the command prompt realm. So you can see, if you copied this whole line and executed it in command, at a command prompt, it would take every item inside of the folder you're currently in and rename it so that it's all lowercase. So this can be really useful if you have a collection of photos or other files, and because some applications will capitalize the extension, so it's like .jpeg and it'll be capital JPG, and some you might have .jpg in lowercase. And if you've ever done anything with like making a website, websites are case sensitive when it comes to interpreting the name of an image or the name of a file. So if you have inconsistent case names, that can really just cause some headaches, and you'll say, why is this not showing up? I know the file's there, but if you're not referring to it by the right case, it's not going to show up. So your best bet is to just keep everything at a uniform, one way or the other. I'm not going to say you have to make everything lowercase, but it is helpful to just make everything consistent in terms of how you are representing it. So that's fun if you wanted to try it out. You could do it. Again, I would say for any of these things that you, when you're first messing around, I would just say copy some data and create just like a temporary folder, a practice folder that you have, so you don't have any files in there that you are willing to lose. Okay, now I would just want to talk a little bit about how you can use a really powerful program called ImageMagick to work with images. So I was just talking about JPEGs. This is kind of the next evolution of working with images. If you just want to convert something, a single file, you can use ImageMagick, and you invoke that by saying magic and then the convert command, and then the name of the file you are converting and what you want the output to be called. So here you can see we are taking a PNG file and converting it into a JPEG, and that's all you need to do. So that you can imagine that might be quite a bit faster than opening up Photoshop, going to save as, and then whatever. So that, and even that is, this is only scratching the surface. Now, if you have a whole folder of TIFF files, let's say, and you want to convert them to JPEGs, then you can use the mogrify command, which is a bizarre name. I'll never understand it. Transmogrify? I'm not sure. But you can use the format switch, -format JPEG, will allow you to convert, and you see I have an *.tiff, and that asterisk is a wildcard. So what that means is everything that ends with .tif, convert it into a JPEG. And so you could do that in a folder with 1,000 TIFFs in it, and this single command would convert all of them into JPEGs. And that's something that's super powerful, and compared to doing it in Photoshop, where you could use the image processor or an action, it's honestly going to be quicker with ImageMagick. You can also resize. So if you have a giant image and you want to create a smaller one, you generally do not want to go from smaller to larger, because chances are you're going to lose image quality, and that's not what we like to see, pixelated images and whatnot. But if you want to make something smaller, enable for it to be displayed on a website or used in a or send it via email, you can use the convert command with the resize switch, and that will cut it, in this case, to half its size. You can combine the options. So you can resize and convert simply by changing the extension of that output from JPEG to PNG. It will convert it, but also resize it. Now that's pretty cool, I think. So if you want to resize multiple files, same idea. But the thing to be aware with Mogrify is that if you're not converting the file format using Mogrify, it will actually just resize it will modify the original. So in this case, this could really be sort of a gotcha, where it would overwrite the existing files with that half-size version. So you don't want to do that. So what you can do is use the -path option and just create a new folder where you see I have folder name, and there you'll just say you'll call it JPEG or something or whatever, and that's where you'll point it to. And so then it won't actually overwrite the existing files. It will create new files and put them in that new directory. Whew. But if you change the file format, then you can do resize, and it'll because it's creating new files, it won't be, I forgot an E on size, it just says is. Half this is. So here you can see this is a very powerful command, and something that is just a handful of commands. Now looking at it, like I said, it's not the most intuitive thing to read and kind of get what's going on, but let me just really quickly walk through it. Magic, that's just the name of the program. Mogrify is the name of the specific command. And then you use two different options, which are indicated with the dashes, -format, -resize. And the options are you specify the format to be JPEG, you specify the new size to be 50%, and then the output, or in this case, the input files, and you're providing wildcard.tiff, which means every tiff inside of the current directory will be the input for the modification. So hopefully that makes sense. And the ImageMagick website, I should say, is really spectacular. It's been around for so long, and there are so many examples out there that if you just Google something you want to do with ImageMagick, chances are you'll see a long discussion of that, that exact thing, which is really can be a time saver. Okay, now I want you to get in a different headspace. Imagine a world where you need to download a whole bunch of files from a website. Now this, I don't know about you, but I know when I was a graduate student, I had a number of tasks as a research assistant where I had to acquire lots of data, lots of just things from websites that are not particularly geared towards large amounts of downloading or downloading many files at once. So for an example, say I wanted to download all of the daily COVID-19 cases for the entirety of the United States. What's handy is that if any of you have seen the coronavirus dashboard from Johns Hopkins, they have all of their data on GitHub, and it gets automatically updated. There's a new daily report created every day. It's as a CSV, it's freely accessible. So here you can see, this is what it is on GitHub. So you can see a URL for each file. That's what it looks like. So that's that long thing, ending with just the date in month, day, year format .csv. So let's just walk through how we're going to get every single one of these without clicking and downloading each of them. So you can take just that date, because the date is the file name. You can use, this is Google Sheets, you can use Google Sheets sort of auto-complete functionality to fill out the rest of the dates, and then you can use some Google Sheets functions to autofill the URL. And if you look here at the end of this, so there you see we have the date, which is the file name, and here we say that equals the root of the URL, which is the same D1, and then we use the ampersand to concatenate those, and then we'll add .csv at the end. And then it suggests an autofill, so we say yes. And then you see at the end, it just had a series of numbers, not the date. And that's because we need to change the format of this column to plain text. So it won't treat it as a date, which in turn actually stores it as a number. We want it stored just as plain text. So we do that. And voila, you get a bunch of URLs. And now we can take all of those URLs, just do Control-C, copy them, paste them into Notepad, save that as a text file, and then we can, this sounds crazy, I know, but we can take a command called wget, use -i and point to files.txt, and it will download every single one of those files and save them in your directory. So there you see we're at a Unix command line here. I put in wget -i files.txt, hit enter, and you see here it's has a little progress bar, and it's showing you the progress and going through each downloading. So there you see it downloaded 21 files in 0.7 seconds. And now imagine that if it wasn't 21 files, imagine it was 5,000 files. And if you created a text file with 5,000 different URLs in it, you could use the same exact command to download those. and it would be just as efficient. So really a very handy tool, pretty easy to use. Like all you need is a text file with URLs on one URL per line, feed that into it, and it will take care of business. It's really pretty terrific. All right, now let's get really academic-y with it here. Let's say we have a just because I'm a maps and GIS guy, let's say we're working with the GeoNames Gazetteer database, which is a CSV file with 12 million rows that occupies 1.5 gigabytes of space. Now, how are you even going to look at this thing? Excel can only handle about a little over a million rows. And yes, yeah, the file for, great, thank you for mentioning that. Let me go back. Yeah, if you see, we have the wget and then -i files.txt. That files.txt in this scenario is what I would save the contents of what I pasted into Notepad here. Imagine I said save as files.txt, which I should have done in that GIF to make that clear. And then you feed that into the wget command, and then you're off to the races. Hopefully that makes sense. I apologize I didn't include that. It's the kind of thing where my brain was making that leap without actually explaining it to anyone other than my own self. Great. So we're working with this GeoNames database. So even Notepad, the simplest plain text editor you could imagine for Windows, you could not open this thing without it just sitting there and waiting. So this is where the command line really shines, is when you're working with just fairly large data. I'm not going to say big data because that's a whole thing, but just large unwieldy data. So we can use a couple of commands called head and tail to work to just get a sense of what we have here. And as you might imagine, head looks at the top. The head command will give you the start, the first, I think by default, it does the first 10 lines or for the first 5 lines of the file. And head and tail gives you the last whatever line. You can specify the number. I can't remember what the default is. So let's see here, just as this is a bit of a mishmash. So you can see that first line, I say head, all countries.txt, and then the greater than sign, snip.txt. So what that first line is saying is take the head, take the first 10 lines of all countries.txt and redirect the output. So instead of just printing it on screen, I want you to take the output and put it into a file called snip.txt. So we took this 12 million row file and condensed it, or took a snippet of it, a 10-line snippet, and saved it in a new file. So then you could open that file in Excel, and that's how you could see what you're working with, do some preliminary manipulation just to see what you want to do with the full 12 million rows without having to sit and wait for the 12 million rows to load, if they ever actually will. Now just for, this is, the next line is a little more complicated than it needs to be, but I just want it to be more kind of real world, is there's cat, and cat is catalog. So that just outputs the entirety of a text file. So what we're doing by saying cat head.txt followed by snip.txt, it says take the contents of these two files and kind of smush them together. In this case, head.txt is the header line, so it's all the different column names for the GeoNames Gazetteer. And so we're saying take that header line, combine it with our snippet. So the 10 lines we got in the first command, the head all countries.txt, redirect to snip.txt. We're combining snip.txt with head.txt and then taking the output of that and putting it onto the clipboard. So then you could paste that into Excel and you'd have your a usable data file right there. I'm sure that's kind of gobbledygook, but we will. I will do a little demoing once I've gotten through the slides, just to show what that actually means. Now let's introduce grep. Grep is a great word. Got to grep it. And grep is a tool to find text within one or more documents. In this case, we're just going to use grep to search through our 12 million row file and extract. So we're going to use it sort of as a filter. So here you can see we're using the command called grep to look for, and if you see those, all right, Beth, take care. Thanks for tuning in. So we have grep, and the -p means this is, I can't even, honestly, I can't remember what -p means. It's something so that it recognizes the tab character, and that's what the /t, the \t represents tab. So we're saying search for tab, capital O, capital A, /tab. So basically I'm saying where a column's entire value is OK, which is Oklahoma. And then to output the contents of every match from that search string into a new file called okla.txt. And the result when you do that is from the 12 million rows of all countries.txt, you get okla.txt, which contains about 33,000 rows, I think. Now, if you wanted to actually get how many lines are in a particular file, you can use WC, which is actually word count. But if you use the -L switch, it turns into line count. So that's how you could very quickly find out how long a text file is without trying to open it and doing that. Now, really one of my favorite things is this command here. Don't actually worry about it, because all it does is it loads a ASCII plain text version of the entirety of Star Wars Episode 4: A New Hope. And we're not gonna watch the whole thing, but it's a really impressively done plain text version of Star Wars. So if you're an enormous nerd like me, you could sit there and watch it. And so that is the end of my slides. And I want to now jump over to a terminal window, if I can figure out how to do it. There we go. So let me, there we go. Let me share terminal. Okay, hopefully everyone can see that. Let me increase the size. Okay, here we go. Well, this is a good example. So you remember I was saying CLS or clear. CLS just clears the content out of that. So let's use CD change directory, and I'm just going to change it to C:\\. And now let's use dir, and there you see that's what dir outputs. So I'm going to use another command that I didn't talk about, but we're going to call mkdir, which is make directory, and I'm going to call it it's me. So now if we use dir again, you'll see that right after Intel, we have a folder called it's me. Now let's change directory into it's me. And you'll see here, I will actually just type in it and then the tab key, and that will auto-complete because nothing else starts with IT other than it's me. And we can go in there. Now let's see, when we do dir of it's me, you'll see that it's empty, but there are two entries there. You see a dot and you see two dots. And the way in the command line world, a single dot refers to your current location. So if I do cd dot, it doesn't go anywhere. But if I do cd dot dot, that takes you to the parent, which in this case is just c:\\. So let's go back to it's me. And now let's create a new file. And this is something we can just, another command called touch, which that's, yeah. Well, you know what, let's do something else. So I'm going to take the content, so dir, and you'll remember I used the angle bracket to do what I call was a redirect. And we're just gonna call it text.txt. So now let's do dir again. Ooh, there you see, there's text.txt. And you'll recall I said we can use cat to output the entirety of our file there. And let's see, what does head do of text.txt? Oop. And here's a good error. And I'm sorry for that very Midwestern oop. That's just what we say when something goes awry. But you see with head, yeah, it must be 10 lines. Let's see. And let's try to get, so here I tried to get the help for head and I used a 1 dash, but I need to use a double dash, or probably just dash H would do it. Nope. So here you see how once you get in the sort of right direction, you can figure it out. So here you see dash N corresponds to the number of lines you want. So let's do head dash 1 of text. No, heads dash N 1 text.txt. There you go. And now volume in drive C is Windows. Let's show the first 2 lines and so on. So that's cool. Now let's see, how can we, let's use grep. Let's use grep, grep. And you can see for grep just how many options there are. Okay. Dash P means that it's a Perl regular expression. So I'm glad I didn't really get in depth on that, but that's how you can search for special characters like /T for tabs. So let's do grep, and I'm going to say serial and text.txt. And there you see it just returned the line where it was matching. And there's that. And I know, let's see, I want to include, okay, I lost my spot, there we go. So let's do grep dash H and dash N serial and star.star, which just means every single file in this directory. So you can see that with the dash capital H, that means include the file name, and then dash N means include the line number. So imagine you have 30 different files with 1,000 different rows or 1,000 lines in each of them, and you wanted to find a particular phrase or word. Using this combination of commands with grep would let you narrow down to the file and the line where these different occurrences are of a particular string, which is pretty cool. So let's do, oh, it's probably escaping. Shooters. There you go. So there you can see it's found I don't know why I only did one or the other. Interesting. I'm not going to get bogged down. So let's do DR, and I can actually use ls because I have cygwin installed here, and you can see ls is a lot simpler than dir. Dir gives you all that jazz. Ls gives you just the name of the file. What if we do ls-a? That includes the dot and the double dot. Let's see, what's enough? Oh yeah, let's do, I want to show you wget. So I just will go to wget and then https:// is it backslash? Yeah. This is making me feel goofy. / and we'll just go to mywebsite.com, and I just happen to know there's a file called butterfly.jpg. And there you see is butterfly.jpg. And we can use, well, just trust me, it's a lovely picture of a butterfly. You know what? Actually, I just want to show you. See, and there's the picture of a butterfly. So that's just an example of wget and just how quick it is. So let me share my screen again. So wget, very cool, very fast. You can use it for password protected things. You can use it, I mean, you can provide the password. You can use it to crawl the entirety of a website using the spider command, and it will grab everything off there. You'll generally get even more than you're looking for. But yeah, I think that's all. I should just stop there because it's just a few minutes till 4. So I can't, and so I'd be happy to answer any questions anyone has.